Hello and welcome to Chapter 4, and I will be describing the chapter in the book which is supporting processors and upgrading memory. Here the chapter starts out and talks about the types and characteristics of processors. And here it's talking about multi-core processors, which is very common these days. I think we're up to 6 cores now, maybe 8. And that means each one of these does its own independent processing of the other, and they can all work together or separately. Here we go, how a processor works. This is the bottom side of the chip here. Excuse me. And the very first thing that comes in, the signals are all controlled through the input-output unit, the I/O unit. And then is brought up here to the control unit. There's an internal memory cache. Here's an arithmetic logic unit, another arithmetic logic unit, and then there are registers for each ALU. And that's exactly what these do, is they do computations. Everything that's inside a computer, everything that happens, is a mathematical computation. Here we go, talking about Intel processors. If your goal is certification, you're going to have to memorize lists like this for the actual exam for CompTIA. Here's what a processor looks like when it ships to you. My recommendation is don't take it out and play with it and look at it and do stuff with it. Just receive it, let it warm up to room temperature if it came in from the cold. Open up the machine it's going to go into, take out of its shipping package, look at it really quickly, and then put it into the machine. The less time it has to spend out in the open, the better. So, here we go, talking about AMD processors. How to select and install a processor. You have to match the processor to match the system needs. Okay, and this is where we're looking at the specs of the motherboard itself. The motherboard manual specifications will be on there or in there, and it'll say AMD only, Intel only, this type of socket, this many pins, and it can only be within this frequency range of this to this. And it won't work outside of those boundaries. So, here's how to install a processor. Be very careful when you do this. Okay, these things are meant to go, this is why it's called the ZIF socket and a ZIF lever, is they're meant to go in with zero insertion force. Okay, you don't want to hear anything go snap or crunch, or there shouldn't be any forcing. It should just very gently place into the socket, very gently close the lid, push down on it a little bit, bring the ZIF lever, the ZIF lever, down into place, push it down, it goes out, and then it goes back in, and it hooks. There's a little hook and a clip there, so that's what holds it in place. Just like this. This is closed with no CPU. You open it up. There's the ZIF cover. There's the ZIF lever. Put the processor in. Close the cage cover. And then very gently push down on the ZIF lever, bring it out, and then in. Next, you're going to install the heatsink. Again, this should be very simple. You don't want to hear anything go crack or crunch. 4-pin standoff for extra power to the CPU fan, or it's called a header. Make sure it's configured properly within UEFI or BIOS. Here's how to install an Intel processor. This technician is wearing anti-static gloves. Processor goes in, cage cover goes down, there's the ZIF lever. Pushing down very gently. That's a lot of thermal paste. There's not really a need for that much thermal paste. What is thermal paste or thermal grease? It's a grease and it has very fine ground silver in it. And why do we use silver? Because it's dissimilar from the copper up top and from whatever metal is here. Because if you had a similar metal, you'd get electrolysis and then things would start binding together. Thermal paste provides, it's the media that fills the gap between the heatsink and the top of the CPU core. So it fills the void, making sure that all the heat can transfer. Hands-on project 4-1, 4-2. You could probably do 4-1 fairly easy. If you don't have the resources to insert and remove a processor, email me. I might be able to find something for you at our school. Do not start this unless you know what you're doing. Email me before, please. Here's for notebooks. Again, being very careful working in small spaces, and again, do not use magnetic tip tools. Touching the component on the very edges. Here we go, talking about memory. Here is a picture of different types of memory. If your goal is to get the CompTIA certification, you're going to have to memorize all of this and more, because it will be on the actual CompTIA test. Here's a timeline of how RAM has developed and progressed. Here's DIMM, dual inline memory modules. Here we talk about single, dual, triple, and quad channeling. Talk about DIMM speeds, single-sided and double-sided DIMMs. Again, if your goal is certification, you're probably going to have to memorize a lot of this. And then we're going to talk about here in the chapter about buffered and registered DIMMs. CAS and RAS latency, types of memory used in laptops. Here's the different types of memory used in laptops. And more. How to upgrade memory. How much do I need and how much is currently installed. The fastest fix for slow computers is install all the memory that you can afford. And I usually recommend to people when they're buying a machine brand new, load it up with as much memory as it can take. Because it's going to need it. And then talking about how many and what kind of memory modules are currently installed. You can also go to a command line, start run CMD, or no, I'm sorry, go start run and then type in msinfo32.exe into the start run box, and that'll pull up all the system information in a Windows machine. Here's the hands-on project 4-3. Use an online memory scanner. How many and what kind of modules can fit on my motherboard? Well, I would recommend reading the motherboard manual. How do I select and purchase the right memory modules? You can use a website to research a purchase. You can consult the manufacturer. You can consult the motherboard manual. And then here's a hands-on project 4-4, plan and price a memory upgrade. You don't actually have to buy it. Okay, just to be clear, it's just a plan. It's not actual spending of money. Hands-on project 4-5, examine UEFI and BIOS settings. You don't actually have to do this. If you know what you're doing, you can. If you don't know what you're doing, please email me beforehand and I can help answer some questions for you. Hands-on project 4-6, upgrade memory. If you know what you're doing, fine. If you don't know what you're doing, email me beforehand and I'll try to help you. And as to note here, see how this person is installing the chips with an equal amount of pressure on both left and right sides? Very important that these types of chips, anything that installs into a slot like this, has to go in equally like that. Hands-on project 4-7, upgrade laptop memory, not a requirement. Please email me beforehand. And then here's the chapter summary, talking about the types and characteristics of processors, selecting and installing a processor, different types of memory technologies, how to upgrade memory. Here's all the key terms. And then reviewing the basics. You can write about some of this if you'd like. Here's some thinking critically questions, and then real problems and real solutions. And that's the chapter.